All right, we're going to do finding the quotient of complex numbers. One quick example. So I have my division problem up here at 4 plus I divided by 3 minus 2I. So what we need to do to solve this is we need to multiply by the complex conjugate. Complex conjugate. It's in the filled in notes at the very end when they're talking about division. The words in there. There might be a question on the quiz or a test about it. But so complex conjugate. What is a complex conjugate? Well, for me to divide, I'm actually going to multiply. So dividing these complex numbers, I'm actually multiplying. So it's going to be a little bit different than actually division. So the complex conjugate. I'm going to take my denominator, which is 3 minus 2i. And I'm going to write the 3, and I'm going to write the 2i, and the 3, and the 2i. Right? So I'm going to do the same thing top and bottom. The complex conjugate, the only thing is that I'm taking this sign, taking that minus sign, and I'm changing it. Making it a plus. That's what makes it the complex conjugate. The conjugate is just means changing that sign. So I'm going from 3 minus 2i to 3 plus 2i. Why? Because it works. I'll show you why it works once we get through the problem, but this is how we set it up. I have to divide, so I'm going to multiply top and bottom by the complex conjugate of the denominator. Simple terms is I have to divide, I'm going to multiply by the denominator with a different sign in the middle. All right, so all I'm doing is I'm going to take the denominator, change the sign, top and bottom, now I'm going to multiply. So I got to do the top and I got to do the bottom. So I'm going to do the top first. And I'm going to do the box multiplication. You may want to do FOIL. I don't care what you do. I prefer box, so that's what I'm going to do. So we have 4. I have I. 4I, and then I have 3 and 2I. Draw my box. 4 times 3 is 12. 3 times I is 3I. 4 times 2I is 8I. 2I times I is 2I squared. All right, so this is going to be, if I go here, all right, so that is now my numerator. And I'm going to go ahead and I'm going to do the denominator here. So I have 3 minus 2i, and then 3 plus 2i. So draw my box, I'm going to multiply, we got 9 here, negative 6i, 6i, and then negative 4i squared. These 6's are going to end up canceling, you get 6 and a negative, so this cancel. I'm going to write this over here. So it's going to end up being 9 minus 4i squared. So I had my dividing by a quotient problem. To solve it, I set up a multiplication of the complex conjugate of the denominator again, which is just taking the denominator, putting it on top and bottom of a new fraction, and changing that middle sign. If the 3 was negative, it would still be negative. So the only sign that changes is the number in between my two terms. There's a sign between the two terms. This is a minus, it becomes plus. If it was a plus, it becomes minus. That's the only difference. I did my box multiplication over here. If we have questions on this, just if you're on my YouTube page, which you probably are, just search in like multiplying binomials, and it'll pop up. It's under the Algebra 1 2020 Summer School, if you want to look in the playlist. So this is multiplying binomials. All right, so now we're down to here. There's a fact that we have to know about imaginary numbers. It's the key one, is that I squared equals negative 1. You can't really see that, but I squared equals negative 1. All right, so it just is. We can go over why another time, but I squared equals negative 1. That is a fact, is a math fact. So everywhere I see a negative I squared, I can put a negative 1. So I'm going to rewrite down here. I have 12 plus 11i, because that's a singular I, so I can't do anything with that. All right, so that's a singular I, so I'm stuck. But this is now a 2 times negative 1. And on the bottom is 9 minus 4 times negative 1. And if I continue to simplify this, here we go. If I continue to simplify this, this is negative 2. 12. Oh, hope it's still recording. Sorry, my screen went off. It's still recording. Cool. So I have a 12. 2 times negative 1 is going to be negative 2. So 12 and negative 2 is going to be 10 plus 11i. 9 minus 4 times negative 1, or negative 4 times negative 1 is going to be a positive 4. Then 9 plus 4 is going to be 13. And that's my final answer. They, meaning Apex, may write it as this, which is perfectly fine. These are both correct answers. So to review, we had our original problem where we had to divide complex numbers. I set up a multiplication problem with the complex conjugate, just taking the sign in between the terms and changing it, minus to a plus, top and bottom. I then did the box method, which is multiplying binomials, to get my numerator and my denominator. I set them up. I remembered that I squared was equal to negative 1. I then identified all my I squareds. I made sure I didn't combine my I and my I squared, right? One's squared, one's not. We can't combine them. I then plugged in a negative 1, and I just simplified my answer. That's it.